Have you ever gazed at the night sky and wondered about the multitude of galaxies that exist in the universe? Well, you're not alone. The cosmos is a vast expanse of mystery, home to billions of galaxies, each with its unique story. Now, galaxies are not just random clusters of stars thrown together in the void of space. No, they are grand structures, swirling formations of stars, gas, dust, and dark matter, each dancing to the rhythm of cosmic forces. There are three main types of galaxies in our universe: spiral, elliptical, and irregular. Spiral galaxies, like our own Milky Way, are disc-shaped with arms that spiral out from a central bulge. Elliptical galaxies are round or elongated spheres, while irregular galaxies are, as the name suggests, irregular and lack a definite shape. Ever wondered how astronomers classify these galaxies? Stay tuned. Imagine a flat, spinning disk with a bulge in the middle. This is a spiral galaxy. These galaxies are among the most stunning celestial bodies in the universe, with their swirling arms of stars and gas. Spiral galaxies are characterized by their distinct structure. Picture a pancake with a bulge in the center. That's your spiral galaxy. The flat spinning disk is made up of stars, gas, and dust, while the central bulge is densely packed with older stars. Extending from the center, you'll find the galaxy's defining feature: its spiral arms. These arms aren't solid structures, though. Instead, they are density waves, areas where stars and gas bunch up, much like traffic on a busy highway. And it's within these arms that star formation predominantly occurs. The compressional nature of the density waves triggers the collapse of the gas into new stars. This makes the arms bright and blue, filled with young, hot stars. Now let's bring this closer to home. Our very own Milky Way is, in fact, a spiral galaxy. It has a central bar-like structure, making it a barred spiral galaxy. With a diameter between 100,000 and 150,000 light-years, it's a pretty sizable one at that. We're located about 26,000 light-years from the center, in one of the quieter suburbs of the Milky Way. But why do these galaxies have a spiral shape? Well, it's all down to angular momentum and gravity. As the galaxy forms, it begins to spin. The material at the outskirts, not held as tightly by gravity, starts to flatten out into a disk. Meanwhile, the denser central region forms the bulge. Spiral galaxies are captivating, aren't they? Their graceful spirals, the birthplace of new stars, and their diverse structure make them a fascinating subject of study. But remember, as mesmerizing as they are, spiral galaxies are just one variety in the cosmic sea of galaxies. Spiral galaxies are fascinating, aren't they? But they aren't the only type of galaxies out there. Now, picture a round or elongated sphere. This is an elliptical galaxy. This celestial body is one of the three primary types of galaxies that astronomers have classified, and it's truly a marvel to behold. Elliptical galaxies, as the name suggests, have an elliptical shape, ranging from nearly circular to highly elongated. They are generally characterized by smooth, featureless light distributions and appear uniformly bright. Unlike spiral galaxies with their flat spinning disk-like structures, elliptical galaxies are three-dimensional, more like an egg or a rugby ball. Now let's delve into the star formation in these galaxies. You might be surprised to learn that elliptical galaxies are largely composed of older, low-mass stars. There's a reason for this. Unlike their spiral counterparts, elliptical galaxies don't have much cool gas and dust, which are the basic ingredients for star formation. As a result, these galaxies aren't producing many new stars. So, where do elliptical galaxies come from? The consensus among astronomers is that these galaxies often form when smaller galaxies merge together, a process that can also use up much of the gas and dust needed for new star formation. Interestingly, elliptical galaxies are often found in the heart of galaxy clusters. These clusters are large groups of galaxies held together by gravity. The center of these clusters is a hotbed of galaxy interactions and mergers, making it a prime location for elliptical galaxies to form and thrive. But don't let the lack of new star formation or their uniform appearance fool you. Elliptical galaxies are fascinating in their own right. They're home to some of the universe's oldest stars, and their formation through galaxy mergers tells a story of cosmic evolution that's as captivating as any. In conclusion, while they may lack the flashy spiral arms or active star formations seen in other types of galaxies, elliptical galaxies are a testament to the rich and varied universe we live in. Elliptical galaxies might seem less exciting than spirals, but they too have their own charm. Finally, imagine a galaxy that doesn't fit into the other categories. This is an irregular galaxy. Now, when we think of galaxies, we often envision grand spirals or massive ellipticals, but not all galaxies fit into these neatly defined groups. Enter the irregular galaxies, the cosmic rebels that defy the norm. Their name says it all. These galaxies lack a regular symmetrical shape, refusing to conform to the standard spiral or elliptical structures. Irregular galaxies are the wild cards of the cosmic deck. They're often smaller, less common, and noticeably chaotic in their appearance. Their irregularity is not a sign of deficiency, but rather a testament to their unique cosmic journeys. So, what's going on inside these irregular galaxies? A lot, actually. They are typically brimming with gas and dust, the raw materials needed to create new stars. This makes them hotbeds for star formation, producing new stars at a rapid pace. This active star production often gives irregular galaxies a blue tint, as young, hot stars tend to emit blue light. But don't mistake their smaller size for insignificance. Irregular galaxies play a crucial role in the grand cosmic ballet. Their gravitational interactions with neighboring galaxies can trigger bursts of star formation, influencing the evolution of other galaxies. Furthermore, the irregular galaxies are often the scene of dramatic cosmic events, such as supernova or the birth of massive star clusters. These events can shape the galaxy, stirring up gas and dust and creating pockets of intense star formation. Contrary to spiral and elliptical galaxies, irregulars do not have a bulge or a halo. Instead, their stars, gas, and dust are distributed more randomly. The lack of structure might make them seem less impressive, but it's this very chaos that makes them so fascinating. Irregular galaxies remind us that the universe doesn't always follow neat patterns. They represent the unpredictability and diversity of the cosmos, showing us that there's no one-size-fits-all when it comes to galaxies. They are the mavericks, the rule breakers, the cosmic non-conformists, reminding us that sometimes it's the irregularities that make the universe so breathtakingly beautiful. So, we've taken a journey through the universe, exploring the different types of galaxies. Let's take a moment to reflect on what we've learned. In the vast cosmos, galaxies are like islands of stars, gas, and dust. Astronomers classify these galaxies into three main categories: spiral, elliptical, and irregular. Each type has its unique characteristics and tells its own story about the universe. First, we delved into the beauty of spiral galaxies. These galaxies are like spinning cosmic pinwheels. They are characterized by their flat, rotating disks filled with stars, gas, and dust, with bulging centers. The arms of these galaxies, spiraling out from the center, are where new stars are born. Our own Milky Way is a prime example of a spiral galaxy. Next, we journeyed to the realm of elliptical galaxies. Unlike the structured spirals, these galaxies are round or elongated spheres. They contain older stars and very little dust or gas, indicating a lack of new star formation. These galaxies vary greatly in size, from dwarf elliptical galaxies to giants that are hundreds of times larger. They represent the end product of galaxy evolution and are often found in the densest parts of the universe. Finally, we explored irregular galaxies. These galaxies, true to their name, lack a regular shape or structure. They are often chaotic in appearance, filled with young stars, gas, and dust. These galaxies are usually smaller and are often thought to be in the process of formation or transformation. Each of these galaxies contributes to the grand cosmic tapestry. They provide astronomers with insights into the life cycle of stars, the formation and evolution of galaxies, and the intricate workings of the universe. The next time you look up at the night sky, remember, each star could be part of a different galaxy, each with its own unique story to tell.